In this tutorial, we're going to be taking our scene from part 2 and adding range display to our character, also displaying the path our character is going to take before they finish travelling. Hello, my name is Aaron, and welcome to the third and final part of grid-based movement with Pathfinding. I don't want to talk for too long because we have a lot to cover, but just letting you know, if this is your first time here, down below there is a link to the repo if you want to follow along with this project, or you could use your own stuff and hopefully this will work for you as well. But let's jump in as fast as we can because we've got a lot to do. So here we are where we left off after part 2, and so far everything's the exact same since part 2. The only thing I have changed, I've changed one minor thing, and that was when we wrote our pathfinding script, there was a get neighbors tile method that get all your neighboring tiles for a specific tile, and because that is kind of map logic that is reusable in other places, I've moved that to the map manager class, and that's all I've really done. And we're going to be changing this in this tutorial, so it's good that it's in here and not in the Pathfinder. So yeah, so that's the only thing I've changed. Step number 1 for displaying range on our characters, we're going to need a range finding class. So let's go ahead and let's create a new script. We're going to name this range finder. We open that up, and now this range finder does not need to be a manual behavior. This is going to be used within our mouse controller, so we can get rid of all this code. And we need just one function. It's going to be a public. It's going to return a list of overlay tiles, and we're going to call it get tiles in range. It's going to take in 2 variables. It's going to take our overlay tile, location tile. That's a weird name. Maybe okay, that's what it'll do for now. Int range. So now we have our starting location. Let's just call this starting tile. That's a much better name. Starting tile and our range tile. Now, first thing we need a list that we're going to use to return. So in range tiles equals new list of overlay tiles. We need a step count so we know kind of how many searches we've done, how many steps we've done through our map. Count, I'm going to say that equals 0. And we need to add our starting tile to our in range tiles. Starting tile. We also need one more list, and that is going to be a list that contains our previous step. So maybe this doesn't make sense right now, but once we start writing our for loop, it will. For previous step equals new list overlay tiles. It's var. And we also want to add our starting tile to this list. So tiles previous step dot add starting tile. Oh, like that. Okay. So now we want to start writing a loop, which is we're going to loop through our map and find all of these tiles within range. We're going to do a while loop, and it's going to be while step count is less than range. For this, we need actually another list now. It's going to be our surrounding tiles, so our neighboring tiles, basically. Tiles equals new list of overlay tiles. And now we're going to have a nested for each loop, and it is going to step through all of our tiles from the previous step. Okay? And the reason we have the tiles for the previous step, technically we could use in-range tiles for this, but because we're using tiles from the previous step, we won't have to research tiles we've already checked. Here we want to add all of our neighboring tiles to our surrounding tiles list. So we're going to do an add range, and we're going to do map manager, dot instance dot get neighbor tiles, and it is going to be item dot grid location. Oh, sorry, just our item. That's just going to take in our item. Now we want to add those surrounding tiles to our in-range tiles. So in-range dot, we're going to add range surrounding tiles. Tiles of previous step equals surrounding tiles, and we're just going to be safe. We're going to make these distinct using link dot to list. So we're only going to add in our unique values just in case. I don't know, just in case we end up with this contains doubles. We don't want that. And we're going to do step count plus. And then finally, once we do that, we're just going to return our in-range tiles, and also we'll do the distinct.toList on this as well. Okay, and that's our range finder. That is going to get us all of the tiles within our range. Now this is missing one important step, and that is height. Because in our Pathfinder, we were checking height here on this line. Our get neighboring tiles doesn't actually take height into account. So what we need to do is we need to move this logic into our get neighboring tiles function. So we're going to do that right now. I'm just going to cut this line. Then in our map manager, in all of these, we're just going to do if, got another layout to these, just like that. And here we're going to do map location to check, grid location Z. So now instead of in our Pathfinder, we're going to check for our height here, 1 being height. Basically, we don't have a value for height right now, so I'm just going to default it to 1. We don't have any character stats or anything like that. So I'm happy enough just having this hard coded as 1 for me. But that is going to be your jump height basically for your character, however you decide to do that. So make sure that's in all of our if statements in here, just like that. And that should be it for our rangefinder. We should have a rangefinder done and it should be working fairly well. Let's actually use it now. So we're going to go into our mouse controller. I'm going to copy this line. I'm going to create a new rangefinder. Call it rangefinder. And I'm going to declare it here. So rangefinder equals new rangefinder. We're going to create a new list. We're going to call it private list of overlay tiles called, and it's going to be our in-range tiles. Just because I feel like this is going to be something that's used in more than one place in the file. New overlay tiles. And then I'm going to write a new function. I'm going to call that function private void get in range tiles. And we're going to do our in range tiles equals rangefinder dot get tiles in range. And this is going to take in our starting tile. And our starting tile is just going to be the tile our character is standing on. So it's character.active tile. And then the range of, we'll do a hard coded value of something like 3. Again, we don't have character stats, so I don't really care. That's going to be up to you to figure out how you want to calculate your range. We want a for each then, and all this for each is going to do is it is going to display all of those tiles within range. So for our item in range tiles, and it's going to be item dot show tile. That's all. And actually, what we could probably do is we could duplicate this here. Or we can do hide tile, because this is now the only time we want to display our tiles realistically. This is how we're going to show the tiles. And within our overlay tile, we can remove, I've already done it. This isn't in part 1 or part 2, but there was an update method here that I've already removed and I forgot. So if you're following along, remove that update method in overlay tile. So back in our mouse controller, let's test that quickly. We'll do after the character gets created, let's do a get in range tiles. And we'll see if it displays our tiles correctly. Let's press play, click our guy, and it didn't work. Because of course it didn't work. That never works the first time you do it. And the reason that's not working is because back in our map manager in our get neighboring tiles, I forgot to flip the signs on the if statement that I added in. So this, instead of greater than, it should be less than or equals to, because of course it should be, obviously. So going to make that change real quick. In Unity, we are playing and we press play and our range is displayed correctly. Wonderful. And only displays once, obviously, for obvious reasons. So we can fix that now as well. Back in our on our mouse controller, where in our move along path function, we're going to add a new if, and we're going to do if our path is empty. So if path.count is equal to 0, we're going to do a new get in range tile. And that will freshly display our range whenever we move, like that. Looks good. Now we need to make our Pathfinder respect our range and make sure that we can't move outside of our limits. And the way we're going to do that is that within our Pathfinder, we are going to give our Pathfinder a limited list of tiles instead of giving it access to our entire map. So how we're going to do that is we're going to give it another variable to pass in, another parameter called, we're going to call this searchable tiles. And we're also going to add these searchable tiles to our get neighboring tiles. So back in our map manager, in our get neighboring tiles function, we are going to give it a new list over tiles. And this is going to be like an optional list. So by default right now, we're using map. So get neighboring tiles has access to the entire map. But in a situation of range, we only want get neighboring to get the neighboring tiles within a certain collection of tiles. So overlay tiles, and we'll call this searchable tiles as well. Tiles. And we want to keep this kind of dictionary formatting. So we want a dictionary here as well. So we're going to go ahead and create a dictionary and it's going to be the exact same as our map. So it's going to be a vector2int and overlay tile. And we're going to call this tiles to search, I guess. That's a bit of a weird name, but okay. Equals new dictionary. Great. And how we're going to set this is we're going to have an if statement. So if our searchable tiles count is greater than 0. So if we have passed in a list here, we're going to do for each within our searchable tiles, and we're going to add that. So we're going to do searchable tiles. We're going to do tiles to search dot add, and we'll have vector2int. So we're going to do item dot grid location. Actually, because our grid location is in 3D space, we're going to go up here to our grid location. We're going to copy this, and we're going to do a vector2int. We're going to call this vector2D grid 2D location, and it's just going to be a getter. So get, and it's going to return a new vector2 int, and that is going to be grid location dot x and grid location dot y. Semicolon, get rid of this semicolon, and great. So we're going to use that instead of having to create a new vector2 int here. Item. Else, if we have not given our getting having tiles a limited list of tiles to search through, we're just going to use our map. So we're going to do tile to search equals map. Right, and now everywhere we use map down here, we're going to change it to tile to search. Boom, 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 boom. Get the if statements as well. And did I get them all? I think yes. If not, we'll find it very soon. Also, in our rangefinder, we're going to need to pass in a new list of overlay tiles. So this is our empty list. So in this situation, we're going to use our full map. But in the pathfinding situation, we're only going to use our in-range tiles. Okay, and now let's see if that worked out for us. We click in our range, it seems to work. We click outside our range and it does not work. Great. Another important note, I can't remember if I did this in part 2 or if I did it. This is my second time recording this because the first time I messed it up. So I can't remember when I added this line in. Just to make sure you check that your tile to search or your map contains the key you're searching for. Otherwise, when you click outside of the bounds on that Pathfinder bit, it might break and it won't work. So now, there we have it. We have our character moving around within a limited range. It also is respecting height correctly. And yeah, so it looks great, looks fantastic, I think, working really well. So now all that's left is to display the path to the user before you start moving, which is another complicated part. I'm going to show you the images that I'm going to be using for this. I have just a list of images, make sure it's centered on the screen for you. I have a list of tiles here that I've already drawn in Airsprite. You're welcome to use them if you want. The important thing to note here is that they are the same size as my tiles, so they fit and align to them correctly. Also, there is some duplicates here that aren't needed, if you can tell, like here and here, or this one and this one is duplicate, this one is duplicate. It was kind of just me drawing in my head, so you don't need 2 files. If you're going to draw something yourself, you don't need 12, you need 10, if that's important to you. But yeah, okay, let's jump into it. So first things first is we need to give our overlay tile prefab a child image that is going to be our arrow. So we're going to create a new empty object within our child. We're going to call this arrow. Let's call it, to be more descriptive, directional arrow. Okay, it's going to be a sprite render. And hang on, I'm in debug mode. Let me just set that to normal so it looks nice for us. And then within our images, it doesn't matter. We're just going to drag one in. And to show you how this is going to look in our map, it'll look something like this. So our arrow is going to be layered nicely on our tile. Let's set that by being visible. And we want to edit our overlay tile script. And we want our overlay tile to basically have access to all of the images we need. So I'm going to create a public list of images. So public list of sprites. I'm going to call it arrows. And that's all. And we won't add to that just yet. I want to do the other script first because it will make this easier to understand. So we're going to do another script. I'm going to call this arrow translator. Okay, so this file is what we're going to use to take in all of our directions and tell us which arrow sprite we should display. So again, this does not need to be a mono behavior, so we can remove it from that. We need an enum that we're going to use to basically for readability. So public enum, and this is going to be our arrow directions. Arrow directions. All of the possible directions we have. And we have a couple now we can do. So because we have 12 images and we have this list, but we also have the possibility of none. So none means we're going to basically hide the tile. So we need 13 values total. So we're going to have none, and that's going to equal 0. Then we have up equals 1, down equals 2, left equals 3. Fix that. Right, white equals 4. And now we have the corner arrows, right? So these are our straight lines, and these are going to be our curves. So we want top right equals 5, bottom right equals 6, top left equals 7, bottom, I'm getting confused by my own head, left equals 8. And now that we have all of our curves, the last 4 we need is our finishing tiles. So the arrow sprites, the ones that are actually arrows. So we're going to do up finished equals 9, down finished equals 10, left finished equals 11, and finally right finished equals 12. And that is our big ass enum done. The most complicated part of this probably. And we need our translate direction function. So we're going to do a public, and it's going to return an arrow direction, and we're going to call this translate direction. Direction. Oh my God, what is wrong with my spelling today? It's atrocious. It's always atrocious, but today's especially atrocious. So I have talked about how I calculate this in a previous video. I say a lot of people have come here from my dev vlog about grid-based movement with pathfinding. So if you want to know kind of a little bit more about how this or a better example of how this is calculated, feel free to watch that again. I explain it a little bit better. I'm just going to go through it, and I'll try to explain it as best I can as I go along, but it's going to be a little bit tricky to properly explain. So we need our previous tile, we need our current tile, and we need our future tile. And using these 3 tiles, we're going to figure out the direction that our character is moving in, and with that, we're going to figure out what tile we need to display, what sprite we need to display. So we want a bool first to say is final, and is final. So we want to know if it's going to be, if this is a last tile or not, and we're going to figure that out by saying it equals if our future tile equals null. So if we don't have a future tile, then we want the last tile. Okay, so that's all we need for that. And now we want to get our past direction, so the direction from our previous tile to our current tile. So we can do vector2int past direction equals previous tile. If it does not equal null, so if this isn't the very first tile that we're using, then we're going to do a current tile dot grid 2D location. Oh, it worked out already. Oh, so it was worthwhile. Minus our previous tile dot grid 2D location. Else it equals a new vector2int 0 0. Okay. And now we're going to do something very similar for future direction. So we want to get our future direction. We copy to paste this line. I'm going to do future direction. If future tile does not equal null, except we need to flip these. So this is future tile and this is current tile. So if future tile minus current tile will give us our future direction. And now we're going to map this to a vector2 that we're going to call direction, and that is going to basically decide the sprite that we're going to use. So confusing, I know. So vector2int direction equals, if our past direction does not equal our future direction, then it's going to be our past direction plus our future direction. Okay, and fine, and then else we're just going to use our future direction. So this is basically covering us if this is our starting tile. This bit covers us if this is our beginning tile. And now we're going to have a fuck ton of if statements, pretty much, right? So we're going to do if direction equals new vector2int. That's going to be 0, 1. So I want you to try to imagine all the possible values, directions we can go, and imagine that as a vector2int, okay? And it's not final. So what does this mean? All right, what does this line mean? So if it basically is going up in y, so if we're going upward and it's not final, we are going to show our straight line. We're going up, right? So we return arrow direction dot up. Does that make sense? I hope this is making sense. Okay. Now this line, these if statements are fairly handy, right? So we've up, and then we're going to minus this, so it's going down, right? Change you to 0 and 1, which means you're going right. Change you to 0 and minus 1, which means you're going left. So these 4 are fairly handy to understand, I think. Now the corners are a little bit more tricky. You have to be more careful with these, right? So for corner tiles, we're going to do if direction, if it equals new vector2int, and if it equals 1, 1. Okay, so imagine this on our graph. So it means we're going up. It's going up and right, 1, 1. Okay, but also this shape here can be done in both ways, right? So we're going up and right, but also if we were going left and down, it's the exact same. It's the same image needed for both of those directional paths, right? So we need to do if within this. We're going to do if past direction dot y is less than future direction dot y. So are we moving down? We're going to return an arrow direction of bottom right, bottom left. Sorry, not right, bottom left. Else, so we're going up. We want to return an arrow direction of top left. Okay. You following? Are you keeping with me? I suppose there's a way to kind of combine these together, like and have both of these have the same value in our direction enum. But in my opinion, this is just so much more readable and it's just a little bit cleaner in my, like, this bit maybe isn't that clean, but having it separated like this just helps really make it sense for me in my head. Yeah, we're going to copy that 3 more times, and now let's do -1 on this value and the same as that. So this is now, so now we're going up and left, right, or right and down. So it's bottom right. No, top left is correct. This here is actually wrong. This should have been top right. God, I hope this makes sense to you. I'm so sorry. I know this is kind of wild. And we're going to do the same here. So now we're going to do, so now we have 1 -1. So we're going right down, and we want to make sure when I invert these if statements here. And so now this is top left, bottom right. And this one is going to be top right and bottom left. That is minus. Okay. So boom, boom, boom. Right. You get it. No, it's complicated. I'm sorry. And then finally, we need to do 4 for our arrows, for our final arrows. So we can copy these lines here. And instead of having is not final, we just check if it is final. Okay. And we're going to change these to up finished, down finished, right finished, and left finished. And else, if none of these work out, we're going to return an arrow direction of none. Whew. And that is our translate direction method done. I'm sure there's cleaner ways to do it, but that's how I've done it, and I'm too lazy to come up with another way at the minute. So that's how we're going to deal with that for now. Now we want to use this translate direction. And now that we have that done, we're going to go back to overlay sprites. I'm going to finish up the bit of overlay code that we had. So we basically here just need a method that is going to set our sprite, our child sprite, to the arrow we want. Right? So we're going to do set arrow sprite. It's going to take a arrow direction. We're going to call it D. Let's include the files we need. And here we're going to do an if statement to say if D equals arrow direction, if it equals none. So we want to basically hide it. So we're going to do get. Let's actually store this in a variable. So we're going to call this arrow equals. We're going to get components in children, sprite render, and it's our first value. Now, there is a get component in children. I find that doesn't work very well for some reason. Sometimes it causes me headaches. This is a consistent way for it to work for me. It still returns the parent's sprite. So it doesn't really work the way as intended, in my opinion. So that's why we're using get components and we're setting it to 1, because the second value that's returned is the image we want to set. And we're going to set its color to be a new color 1 1 1 0. Okay. No, I didn't actually want to set its color here. Sorry, I forgot what I'm doing. So in here, we're going to do arrow dot color equals new color 1 1 1 0. Okay, so we're setting our image to be invisible. You could set the component to be disabled, but I think this is just a nice way of doing things. And else, so now we set our value. Else arrow dot color equals new color. So we're going to set it to be visible. 1 1 1 1. Wonderful. We're going to set our sprite. So we are going to do a arrow dot sprite equals arrows. Not arrow, arrows. It's going to be, we're going to convert our D into an int. Okay, so this list that we've created of arrows is going to need to match our enum number for number, and that will make this work. And finally, we want to make sure our sorting order is correct as well. So we're going to do arrow dot sorting order equals our game object dot get equals our get component sprite render dot sorting order. Great, and that should be our overlay tile done. And we have one more bit that is a little bit complicated, and that is actually adding the images to match. Sorry for the interruption, guys. This is Aaron from the future. I was just editing the video and I realized my stupid face is blocking the list of arrows, the list of images that I was adding in. All you need to know is that all of these images here match the enum that I have here. So let's use it so I can prove that it works really well. So here on our mouse controller, there's a couple of things we need to do to get all of this working nicely. We want to remove our finding path functionality from our mouse click. We want the mouse click. We want to already have the path when we click, basically. So every time we move to a new tile, we're going to find a new path. Every time we focus on a new tile, we're going to find a new path. So right above the mouse click, we're going to add a new if statement. And we're going to check if we have tiles in range. So if we have found some. So we're going to write a new if statement to check if the tile that we're focused on is within range, because we don't want to find a path unless we absolutely have to. So we're going to do contains and overlay tile. So our main overlay tile that we're focused on right now. And as well, we want a boolean as well so we don't end up duplicating some things. So we only want to find a path if we're not currently moving. Otherwise, moving our mouse around could break things. So we want to make sure we limit that. So we're going to have a new boolean called is moving. That's going to equal false by default. Private boolean is moving. And in here as well, we're going to do and we are not moving. Is moving. Not in, is moving. Okay. So now we can find our path here. So we're going to take this line, we're going to get rid of it, and we're going to put it here. Okay. And down in our move along part, because now we would just start moving instantly, we need to use that is moving variable and is moving, right? And then here, in our else where part used to be, we're going to say is moving equal to true. So mouse click is telling us to use the path that we have and start moving. We're going to edit our hide tile function here to also set our arrow sprite to none. So arrow direction dot none. And because this is happening all the time, we want to be always basically setting our sprites to none before we set them to something else to override the past tiles, which is a bit messy, but it's what we're going to have to do. And in range tiles, so we're going to set all of our tiles, all of our sprites to none. Item dot set arrow sprite arrow direction dot none. Include our arrow direction here. So we need to obviously create an arrow translator. So we need to do private arrow translator equals new arrow translator due there. And now that we're making sure that everything is already none, we want to loop through our path, and we want to set our arrow. We want to translate all of our directions. So we're going to do for int I equals 0 while I is less than or equal to path dot count. And now we want to find out what our previous tile is. So var previous tile equals while I is greater than 0. So while if it's not the very first tile, we're going to do path I minus 0 or I minus 1 to get our previous tile. And then otherwise, if it's the first step in the path, what our starting tile is our character.active tile, where our character is currently standing. And now we want the future tile, and that's going to equal while I is less than path count minus 1. We're going to do it equals path I plus 1. Else it's null. Okay, so we have our previous and future tile, and now we want to do var arrow direction is going to equal arrow translator dot translate direction, and that is going to be our previous tile, our path I, and our future tile. Okay, and now path I dot set sprite is going to be arrow direction. Okay. I think we might be done. Hopefully I'm not forgetting something. I probably am. Let's go into our scene. We're going to click. We're going to move around. It looks like we have our range being displayed correctly. Only once though. And the reason it's only working once is because we need to set our is moving back to false once we've stopped moving. Equals false. And now in Unity, we click. Our range is being displayed nicely. If I click away, it'll use the latest, the last path, which I think is fine. I think that's okay. And if I go up to our little thing over here, I'm just going to test that all of these little paths work as well. All of the other directions work. It looks pretty good. And that is fucking that. Grid-based movement with pathfinding. Done and dusted. That was a beast. And I know it was kind of nuanced and maybe a little bit particular to my scene. Everything before was kind of for anybody, and this was a little bit particular. But hopefully, if you're trying to do something similar, this did at least give you inspiration or helped you figure it out. It works really nicely for me and the game I'm making. So hopefully it'll work for you, and I hope it wasn't too confusing. just comment below if you need more help or anything, or just download the repo below and you have all the files there and all the code there. You can just copy and paste it and bastardize it to whatever it is you need it to do. And yeah, I hope that's it. I am tired and I'm not doing another one of these for a while, that's for sure. But if you've made it this far and you've done all three tutorials and you've watched it all and you liked it all, just thank you so much. That was fair play to you. Fair play to you, because I don't know if I'd be able to get through that. I barely got through it and I was recording it. So fair play to you. Thanks so much, and yeah, give me some feedback. This is my first ever tutorial. Give me some feedback, and yeah, thanks very much. I'll see you next time. Cheers, guys. Bye.